Parallel circuits. What direction does the charge flow out of the battery? Well, that's plus, that's minus. So the charge must go from plus to minus that way. Okay? So this is the resistor. This is the voltage. So V equals IR. So if I want to know the current, it's V over R. So if I do 9 divided by 10, you get 0.9 amps. So I is 0.9 amps, and the voltage there will be 10 times 0.9, which is 9 volts, which is what we started with, but we only had one resistor. Okay, let's go to a second problem. Okay, now these are in parallel, and you can tell because they're parallel, like railroad tracks. So for parallel resistors, 1 over Req equals 1 over R1 plus 1 over R2 plus 1 over R3, however many there are. So it's a little more complicated, right? All right, now voltage in parallel. That's right, I said voltage. The V, the equivalent voltage, is the same across all of the parallel components. Okay, so that means there's 9 volts here and there's 9 volts here. And I can make a little table, put current position here, and there's 1, 2 resistors. Okay, and I could have voltage measured in volts, and again current measured in amps, and resistance measured in ohms, and I could have power in watts, right? And a total or equivalence. Okay, so I had 9 volts to start. That means I'm going to have 9 volts for each element. Now, which way does the current go? Well, in this loop, it's going to go around like that. And in the other loop, it's going to go around like that. Now, think about what that means for voltage and power and brightness of bulbs and things like that. Okay, so I need to find the equivalent resistance. So if I was to make a new circuit and have it only have one resistor and call it the equivalent resistor with the equivalent voltage of 9 volts, what would that equivalent resistor be? Well, I'm going to do 1 over Req equals 1 over R1 plus 1 over R2. Well, so this one's first, this is going to be R1, and that's going to be R2. So I'm going to have 1 over Req equals 1 over 3 plus 1 over 6. Now, you feel free to use a calculator, but if I want to do it without one, get a common denominator of 18, and then that'll be 6 over 18, 3 over 18, so 1 over Req equals 9 over 18, or a half. So if I take the reciprocal of both sides, Req equals 2. So this is 2 ohms here. Oh yeah, and R1 was 3 and this was 6 from the original problem. Alright, so, well, I can now use V equals IR. So I is V over R. So I can use 9 volts over 2 ohms, and I get 4.5 amps. And I can also do 9 over 3 and get 3 amps, and 9 over 6 and get 1.5 amps. So those add up to 3 and 1.5 is 4.5, so that's right. So now power equals IV, so I can do 9 times 3 is 27, right? And 9 times 1.5 is 13.5. And 9 times 4.5 is 40.5. And those should add up to 40.5 watts. Okay, let's look at one more problem. Problem 3. And we already have a table set up. So I know that this is going to be 6 volts through all of them. So 6 volts there. R1 is 10 ohms. R2 is 20 ohms. R3 is 30 ohms. And if I resolve that picture, that circuit, resolved it, I could get a equivalent resistor that replaces all 3. And I have an equivalent voltage of 6 volts. Now my equivalent resistance, I'm going to have to do some math. So 1 over Req equals 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over Req, or equivalent resistance, is 1 over 10 plus 1 over 20 plus 1 over 30. So I can use a calculator, or I can do this old school. Common denominator of 60. So that'd be 6 over 60 and 3 over 60 and 2 over 60. So 1 over Req is 11 over 60. So that means Req is 60 over 11. And I checked that with the calculator, and I end up getting 5.45 repeating ohms. So you can see that my equivalent resistance was less than the resistance of each resistor, which is interesting. So now I could find the equivalent current. So IEQ is going to be V divided by R. So I take 6 divided by 5.45 and I get 1.1 amps. And then I could do 6 divided by 10 and get 0.6 amps. And 6 divided by 20, you get 0.3 amps. And 6 divided by 30, you get 0.2 amps. And notice 6 and 3 and 2 adds up to 11 or 1.1. Now my power, 3.6, 1.8, 1.2, and 6.6 watts. Okay, now you're probably thinking, well, couldn't I just skip the table or skip the drawing and go right to the table? Well, you could on simple series or parallel, but you're going to need to be able to resolve or simplify circuits that have both series and parallel parts of them, and so redrawing pictures is the way to go.